Hey guys, so I gave you an assignment to work on today called the Doppler Shift, and it's a kind of a tricky assignment, and since I'm not going to be in class, I wanted to give you a little bit of help if I could. So I'm going to go over the example and show you how I go about solving the example, and if you need to watch this to help out, then great. So let's get started. Alright, so you are given this formula right here: speed of a star over speed of light is equal to the difference in the wavelength over the stationary value of the wavelength. And you're also given the speed of light to be 3 times 10 to the 8th power in meters per second. So I'm going to write that down here. Hold on a second. Here. So we have 3 times 10 to the 8th power. I'm not going to put the units right now. That's our speed of light. And in the example, the thing we didn't know was the speed of the stars. Actually asking, can you calculate this? It gives us the information over here, the difference in wavelength. It says that it, let's see, shifted from 450 nanometers to 498. So it's getting longer. If it's getting longer, that means it is shifting towards the red. So it's a red shift, which means that this particular galaxy is moving away. Okay. Now I could do the math here real quick and say, okay, what's the difference? 498 minus 450. And to keep me from just having to write this out, if you do that, you subtract the 2, you get 48 nanometers. That's the difference in our wavelengths. Again, I'm not going to write the units just to kind of save room here. And it says the stationary value for the wavelength. So read the problem carefully. It says one of the lines for hydrogen has shifted from 450 to 498 nanometers. So it started off being stationary at 450 nanometers and has shifted to be a longer wavelength. So that's our stationary value, 450. So I do the cross multiplying method here of solving this, and before I even cross multiply, I also like to turn everything into scientific notation. You could do it the other way. You could turn this into standard notation, but I prefer to do this. So I'm going to say 48 is the same as saying 4.8 times 10 to the first, and 450 is the same as saying 4.50 times 10 to the second. Right? I cross multiply, so this becomes 4.50 times 10 to the second x. Right? Because I'm multiplying that x into that. And this other one, 4.8 times 10 to the first times 3 times 10 to the 8th. Remember the rules of scientific notation. When you multiply your scientific notation, you add your exponents. So 8 plus 1 is 10 to the 9th. Right? And then I just do my 3 times 4.8, which 3 times 4.8 equals 14.4. There we go. Now I know this isn't the right way. Remember, our coefficient has to be between 1 and 10. I'm not worried about that yet. I'll fix that when we get our final answer. So now over here, I divide my 4.50 times 10 to the second. Do the same over here. Here, they cancel. There we go, leaving us with x. And here we divide. Now, again, our rules, if we are dividing, we subtract our exponents. So 10 to the 9th minus 10 to the 2nd is going to be 10 to the 7th. I love how this program makes all my circles look like weird triangles. And then 14.4 divided by 4.5 is 3.2. And if we go back to our units, we'll know that our units for the speed was meters per second, and there's our final answer. That star is moving at 3.2 times 10 to the 7th meters per second. And since it's redshifted, it's moving away from us at that speed. All right. As you go through these problems, you're going to see a bunch of different questions like what's the difference in the wavelength? Pretty simple. Just do some subtraction. Speed of the star. I just showed you how I go about solving that by cross multiplying. And answering questions like is the star moving towards or away from us? Now remember, if the wavelength gets larger, that means it's shifting towards the red end, which is a bigger wavelength. It's moving away. If the wavelength gets shorter, then we're going to have a negative number for the difference, and that means it's blue shifting. It's moving towards us. Give these all a try. Some of them are going to be kind of challenging. Help each other out, and we'll talk about it on Wednesday.